Problem number 5. We want to prove that triangle BAE is congruent to triangle LAE. And we're going to start with the first given statement, which is that AE is the perpendicular bisector of BL. Well, if we're given that information, what statements can we make from that? And the statements that we can make here are that angle BEA and angle LEA, they are right angles. And that's the definition of perpendicular bisector, and let's mark those symbols in there for the right angle part. But there's two statements here that have the same reason. So that was the perpendicular part, and then the bisector. Well, also we can say then that BE is congruent to LE. So this segment is congruent to that segment. I don't know why I put two tick marks in there. It doesn't matter. We've got it marked appropriately. So our next statement is given to us, and that is that angle BEA and angle LEA are congruent. Well, that is the right angle theorem. So we have that information. Something else that you may have noticed is that we can say that AE is congruent to AE, and that is by the reflexive property. And then what we see is that we've got a side, an angle, and a side in this triangle to the left. And then we've got a side, an angle, and a side on the triangle to the right. So we can say that these two triangles are congruent by side, angle, side. So flipping over here, you may notice that these problems on page 32 are the same. So I'm going to flip over to 33 to finish up our problems here. And you've got to be able to see the picture for starters. A little bit longer proof this time. And we want to prove that M is the midpoint. Still can't see the whole picture. And that's crooked here, but I will straighten it up just momentarily. And we want to prove that M is the midpoint of YZ. So let's see what I've got going on here with this camera. There we go. So what are we given here? We are given, first of all, that XY is congruent to XZ. We are also given that XM is parallel to YZ. And we've seen this here on one of the previous problems. Now, when we're given this perpendicular statement, we can say that angle XMY and angle XMZ are right angles. And that is going to be our definition of perpendicular. Our next reason is given. It's reflexive property. But before I get too far along, I better mark this. X, M, Y and X, M, Z are right angles. And now we can say, for the reflexive property, that XM is congruent to XM. And we'll mark that up in our picture as well. And consequently, we have enough information here to show that our triangle that's kind of on the top, which we'll call triangle XYM, and I think I'm going to go XMY, is congruent to triangle XMZ. And what we have is, we have a right angle in here, and if we look across this right angle, that's going to be the hypotenuse. Look across this right angle, that's the hypotenuse. And then we've got a leg of the triangle. This is called the hypotenuse leg. So we can say those are congruent. And once we know that those two triangles are congruent, then what we can say is, and I want to be able to go back up to the picture here for a second. We can say that YM and ZM are congruent. So YM is congruent to ZM. I'm trying to adjust this camera here, and I'm still not doing very well, as you can see, because we can't see the picture along with all of the statements. There, we can almost see it. But YM is congruent to ZM from corresponding parts of congruent triangles are congruent. And then consequently, what that means, again, if we go back and look at this picture, now that we've said that this length and this length are congruent, then our last statement is that M is the midpoint of YZ, the entire length there, and that is, by definition, of midpoint.